Hello students, today we'll be discussing about the JEE mains paper that was conducted in 2017. So here onwards we'll be discussing all the 30 questions one by one, the concepts and the tricks to solve the questions of JEE 2017 mains physics paper. Okay. Now the next question is about the question number 14, which is about the electric dipole. So this electric dipole question, uh, what is the question? The question is an electric dipole has a dipole moment P, because we know the dipole moment is P, okay, and that is Q into the distance between the two charges, that is Q into 2L. That is, if we have a plus charge Q here, minus Q charge here, two equal and opposite charges separated by a definite distance, finite distance, say 2L, then I say Q into 2L. This is the dipole moment, which is represented as P. So this is a vector which is just like your magnetic dipole. It is always directed from south to north, so it is directed from negative to positive. So this is the direction of dipole moment. So this is a vector. So if I have a vector like this is a vector. Suppose this is a p vector. This is a dipole moment. Now in this dipole moment, which is one end is your negative charge of this value and other is of this value. So this constitutes a dipole. Now which makes an angle theta with the x-axis. So this makes an angle. It says that the question says that it makes an angle of this x-axis. It makes an angle of theta. When subjected to, so this makes an angle theta when subjected to an electric field of E1 equals to E I cap. So what is the nature of electric field? The nature of the electric field is like this. This is x-axis, so because unit vector length, this is I cap. So electric field is magnitude is E, and that is I cap. This is a electric field E1 vector. That means the electric field which is acting in this direction is E1 vector, which is given by E times the unit vector, that is this. So this is along this direction. Now if this dipole is subjected to electric field like this, I apply this field here over here, because this field is in this direction only, in this direction only. So this dipole is placed here in this electric field. So when this dipole is placed in this electric field, which is only in this direction, then what will happen? This is P and this is your E1 vector. So we know that there will be a torque. So it experiences a torque of tau 1 or T1. The T1 torque is given by tau K. This is the torque given. Okay. Now when subjected to another electric field E2, so we have another situation that also you have to understand, that this dipole here is P. The question says that when subjected to electric field E2, which is this, in j cap direction, magnitude is root 2 of E1. So the earlier magnitude is E, E1 vector magnitude is E, here also that is also E, magnitude is same, and in this direction. So first electric field vector is magnitude E, the second part of the electric vector is root 3 times the E, is acting in y direction, that was acting in x direction. It experiences a torque of minus of this value. So whatever torque it experiences minus of that. The angle between them, and the angle theta, is how much? Now according to this, the second case, that this is how the electric field is acting. The electric field value in the second case, this is E2 vector, is the first E1 vector root 3 times E into j cap. So in y direction. So this is the magnitude. We are interested in the magnitude. Now, now if this is the angle theta, as initially, then this angle will be 90 minus theta, because this line this line makes an angle of 90 degree. This is your x-axis or I cap vector, this is your y-axis or j cap vector. So if one is theta, other will be 90 minus theta. So now the torque experienced in this case is suppose T2. Now given T2 torque is minus of T1 torque. That means torque is equal and opposite. Now if I write the torque for the first case, then T1 equals to, because the torque is given as P cross E. This is the formula you have to understand. The P cross E, that is PE sine theta. This is the formula for, this is the magnitude of this, and P cross is like this. It is, and the other one is like this. So equal and opposite direction. So therefore T2 and T1 are given, magnitude is same but opposite direction. So in terms of magnitude they're same, and we are interested in this angle theta, so we'll take the magnitude. So if I take the magnitude on these both sides, then obviously I will have T2 equals to T1. In terms of magnitude, the term is same. So first term is this tau 1 is P sine theta, because the angle was theta, and the second case, that means this case, because this is 90, so PE sine theta, E is obviously this. So I write first PE1 here, then for second case I will write PE2 here, and sine of theta is 90 minus theta, so I'll write 90 minus theta. This comes out to be PE2 cos theta. Okay, so this is the equation, this is another equation. The equations are both are same, so equate these two. That implies PE1 sine theta equals to PE2 cos theta. Okay, the same dipole is there, so we will cancel. E1 is E, in terms of magnitude it is E, so it is E sine theta. E2 is root 3 times E, so it is root 3 times E and cos theta. Here electric field is E, both sides will cancel out. So here it is sine theta, here it is cos theta, so it is this comes to the other side, it is tan theta. Sine theta divided by cos theta is tan theta. Tan theta is root 3, so therefore theta comes out to be 60 degree, because tan 60 is root 3. So if you see the question again here, you can see the angle theta is 60 degree. So the option number 3 is correct. Okay, thank you.